Welcome back. So, today we're going to wrap up our graphing for the rest of the school year. All right, this is the last lesson that incorporates graphing into it. So, now you've actually already done all of the skills we need in this section. It's just encompassing all the skills we did the past 2 days. So, we're just going to run these problems from start to finish. So, let's take a look at what that looks like. Now, because these are longer, I only put 3 examples in this notes. So, step 1 from start to finish is look to see, can you factor? And in this case, yes, I can. The top factors to x plus 4, x minus 3, two things that multiply to negative 12 and add to positive 1. The bottom is a difference of squares. All right. So, now if you notice, in this case, there's actually nothing that cancels. Okay, so that's kind of a unique situation where with nothing canceling, that means there are no holes. Okay, so in this case, we're not going to get a hole, but we do get 2 vertical asymptotes. One from here, because I can't let x be negative 2. One from here, because I can't let x be positive 2. So here I have 2 vertical asymptotes to worry about. Right like that. Okay? So, now let's talk about horizontal asymptote. So, the degree of the top, well, the degree of the top is a degree 2, and the degree of the bottom is also 2. So here we're going to employ the same over same rule. Well, the coefficients are 1 divided by 1. So I'm going to have a horizontal asymptote at 1. All right? So I have all my asymptotes set up. So now let's go and look at our other points. Okay? So our other points are x-intercept, which is plugging in zeros for my x's. All right, well, let's go and plug in the zeros for my x's. So 0 plus 4, 0 minus 3, 0 plus 2, 0 minus 2. So I have 4 and negative 3, 2 and negative 2. So negative 12 over negative 4. So my y-intercept is at 0, 3. Okay? Again, all I did, plugged in zeros for my x's and ran with it. So here, my y-intercept is at 0, 3. My x-intercept is where I just set the numerator equal to 0. Okay? So the numerator being equal to 0, well, that gives me 2 x-intercepts. Okay, I get 1 x-intercept when x is negative 4, and another one when x equals 3. 1, 2, 3, 4. So I have 1 back here and 1 right there. And we already said we don't have any holes this time. All right, so that's what I've got so far. So let's plug this into the calculator, shall we? So we can check just to make sure that this works. Now, there's 2 ways to type this in, all right? You can type in the original equation, which is the x squared plus x minus 12 divided by the x squared minus 4. Or you could type in the factored form, but if you type in the factored form, you're going to want extra parentheses around the top for x plus 4, x minus 3, and then extra parentheses around the bottom, x plus 2, x minus 2. All right? So, and you'll see when we graph them, you get exactly the same thing. It just depends on which one you feel like graphing, okay? Just note if you use the factored form, you do want to use extra parentheses around them to make sure you get the same thing. But notice you did. And notice this is a really cool looking graph, okay? And the reason that you look at this is so you know where your branches go. So here, now I know that my branches go like this, go like this, and go like that. Again, you do need all of the work leading up to that. I just like the graphing calculator as my final step, so I know that I'm doing it right. All right. So, whoops, I think I went too far. All right, so let's take a look at this one now. So, looking at this, again, the first step is factoring. So we have x plus 3. This is going to break up into x minus 5, x minus 1. Right now, again, notice nothing actually cancels here. So there won't be any holes, but I have two vertical asymptotes. One because I can't let x be 5, and one because I can't let x be 1. So my two asymptotes are at that 5 and 1. 1, 2, 3, 4, 5. All right. So when they don't cancel, they're vertical asymptotes. If they do cancel, then they're horizontal asymptotes. All right, now, or sorry, not horizontal. If they do cancel, they're holes. I'm sorry. So horizontal asymptote. Let's interpret the degrees here. So the top is a degree 1. The bottom is a degree 2. So we're going to employ the rule of less over more, which is going to mean our horizontal asymptote is going to be at 0. Whenever you have a higher degree on top than the bottom, you're dealing with the horizontal asymptote of y equals 0. So now let's look at the other pieces, all right? So the y-intercept. The y-intercept is where I plug in 0 for all of my x's. So I get 3 over -5 times -1. So I end up with 3/5. So my y-intercept is at 0.6. Right, so 0.6. All right, and what about my x-intercept? Setting the numerator equal to 0. Well, that gives me a -3. Now, this you may find odd because you have the horizontal asymptote sitting there. So how on earth can you have an x-intercept? Well, the thing about asymptotes, especially horizontal asymptotes, is they are the long run. So horizontal asymptote, what it means is in the long term, it's approaching it, but in this instance, it's actually going to cross over it before approaching it. Okay, and I'll show you what that looks like graphically, but just note sometimes this can actually happen. It is not a mistake on your part. And then there is no hole again. So let's go and type this into the calculator. Now again, I'm going to show you how to type it in both ways, just so you're comfortable with whichever one you want to use. You can type in the original function of x plus 3 divided by x squared minus 6x plus 5. If you want to type in the factored form, again, just make sure that you use extra parentheses for the x minus 5, x minus 1. And you'll see that they are going to turn out exactly the same. Oh, I'm sorry, what happened? Go to... Oh, I typed in one extra parenthesis. There we go. Now it should work. All right, and now that I can see that general shape, now let's go and put it on our paper. So the general shape is coming down, and on this side it actually crosses and then approaches from the bottom. Here it just approaches from the top, then it has the little loop-de-loop down there, kind of the upside down parabola looking thing right there. And again, that's what I'm looking for in terms of work for your graphs, okay? You need to show me all the work, then use a calculator to kind of help you sketch it. All right, last one. So again, first step, factor cancel if possible. So here I have x minus 2, x plus 1, multiplies to negative 2, adds to negative 1. Then this one, x plus 5, x minus 2. So notice the x minus, whoops, I'm sorry, that wasn't supposed to drag like that. So those x minus 2's cancel out. So this really reduces to x plus 1 over x plus 5. This one that stays, x can't be negative 5, that creates my vertical asymptote. 2, 3, 4, 5. Okay, that's what creates a vertical asymptote. The hole is from the piece that canceled. So I have a hole at x equals 2. And we'll come back and plug that in a little bit. Okay, I just want to keep going in the same order for the sake of consistency. The horizontal asymptote. Now notice it actually doesn't matter what you use here. Degree 2 divided by degree 2 or degree 1 over degree 1, both of them employ the same rule of same degree over same degree. It doesn't matter if you use the original or the reduced. The rule is the same. And so we're going to use that same over same property. 1 over 1, 1 over 1, turns out the same. Both of them give you a horizontal asymptote of y equals 1. All right, so we have our asymptotes. So now let's go and talk about the y-intercept and x-intercept. So plug 0 in for x. So here I'm going to do it in the simplified version. Okay, so the 0 plus 1 and the plus 5. Okay, so I'm going to use the reduced formula. So my y-intercept is at 0.2. So that's really, really close to the origin, like really sitting right there. X-intercept, when the numerator equals 0. Again, I'm going to use the updated one, the reduced one. So my x-intercept is going to be at -1. And the whole is sitting at 2. So I'm going to plug that in. So my whole is sitting at 2/3, or a little, or about 2 and 0.5. All right. And again, you do need to indicate that you have that whole where x is 2. All right. So just as best you can, put a hole at that spot. I know oftentimes, excuse me. I know oftentimes it's going to be kind of a nasty fraction. So honestly, just do the best you can with it. All right. I'm not looking for perfection. I know these are nasty decimals. I'm just looking for the best that you can. Now that I have all of that worked out, now let's plug it in to the calculator. And I want you to see once again that there's no difference in whether you plug in the original, so the x squared minus x minus 2, versus if you, oh, not done with the original yet, sorry, plus 3x minus 10, or if you plug in the reduced one. I want you to see that they give you exactly the same thing. All right? So just plug in either one to get an idea of what the graph is supposed to look like. So here you can see you have your two branches. The only thing it doesn't show you is the whole. Okay? So, but based on our work, we can see that we've been doing this right. So I'm just going to finish connecting up. I know I have a branch there. I have all of these points here. And that's what my graph looks like. Okay, so that's what these problems are like from start to finish. Okay, I know they take a little bit of time, but as long as you're diligent and you go through them, they are all completely doable. All right, so what I'd like you to do is flip the page. That's where your summary is. Sorry, I couldn't finish or fit it on the bottom of this page. So there's your summary. Make sure you write that for me and then come back ready to do your practice work.